So yeah, good evening again. I hope you people have put your attendance. All right. Yeah, that's great. All right. Five people. So guys, today's our subject is network analysis, right? So let me just present my screen. Yeah. So I will just quickly recap uh, whatever we have seen in the last class. I hope my voice is clearly audible to you. It is not breaking or there isn't any kind of background noise from my side. Clear? Yeah. Thanks. Okay. Good. Yeah. Fine. So in the last class, we have seen source transformation, sources in parallel and series. After that, we have seen Y delta transformation, isn't it? And then we have solved some examples in which we have to find out voltage across an element or current through and branch. Okay, so these are the examples we have already seen, and this was the homework I had given you. So uh, did do you guys solve this? आप लोगों ने solve किया? Did you solve this? Like I'm just asking if you face any difficulty or something like that. If you solved it without any difficulty, that's absolutely fine, but if you find any difficulty, we can discuss it. Okay, so yeah, this is not a fresh topic, so we'll discuss about this example at the end of the class if needed. Okay, so we are going to start the fresh topic, that is Thevenin's theorem. Okay, so why Thevenin's theorem is used, or why it is there. So the resistance across 10 ampere was not given. Srishti, actually the value of that resistance is not required. Okay, so that is why it is not given. Just try solving without the value of that resistance. I hope you will get the answer. Okay, if not, we'll discuss it. All right. So Thevenin theorem. I guess everybody has at least heard the name of Thevenin theorem, isn't it? So what exactly is it? So let me just simplify this. Thevenin's theorem is applicable for linear and bilateral network. Now, what is linear and what is bilateral? So I have already told you the definition of bilateral network, or what is bilateral network. So if a circuit contains bilateral elements, so which is bilateral element? Resistance is a bilateral element. After that, capacitance, inductance. So these like capacitor have polarity, but it is for network analysis we don't use that kind of a, or the capacitor with polarity. We just use simply capacitor. It do not have any polarity in network analysis or networks only. Okay, so Thevenin's theorem is applicable for only linear and bilateral network. Now linear is what? Linear means the VI characteristic or the graph of voltage versus current is linear for a device, then that device is said to be a linear device. Okay, so this theorem is applicable for linear and bilateral network. That means the network which contains linear as well as bilateral networks, sorry, elements. Now, what is the purpose of this Thevenin's theorem? Why do we use this theorem, and why it is necessary? So it converts a complex circuit into a simplest equivalent form. Okay, let us suppose we have given one bulky complex circuit, and we need to simplify it. Then this theorem is useful. All right. So how does it simplifies? We'll see. Let us suppose. Let me just write here. Okay. So this is a circuit. This is very complex circuit. I'm not drawing it actually. Okay, so this is complex circuit and it has some load. Okay, this is suppose load RL. So this is a complex circuit and it has some load RL. So this circuit can be simplified with the help of Thevenin theorem. And what do? We simply put one resistance in series and we have one voltage source, and we have the load resistance RL as it is. So this is RL, this is called RTH, this is called VTH. VTH is nothing but Thevenin voltage and RTH is nothing but Thevenin's resistance. Okay, so we have to make some calculations on our circuit. We have to make some changes and we have to find out two values. Which values? We have to find out VTH, we have to find out RTH, and we will put RTH in series with VTH and RL will be as it is. So this will be the our simplified form of given circuit. Okay, so how to calculate VTH and how to calculate RTH, these are the important things when we talk about Thevenin theorem. Okay, so how to calculate VTH? So let me just give you one example. Okay, so how VTH is calculated? Now, let us suppose you have given one circuit. You have one circuit. Okay, and what you have to do? You have to calculate VTH across it. Okay, or the VTH of the circuit. So let me just draw one circuit and you try um finding the VTH. Okay, so see, let us suppose as a circuit we have is this is one resistance, this is again another resistance, this is third resistance, we have one voltage source here. Okay, and after that a resistance here, then a current source here, and again a voltage source here, and this is RL. This is RL. The value of this voltage source is 3 volt. This is 2 amperes. This is 2 ohm, 4 volt, 3 ohm, 2 ohm, and 2 ohm. Okay, so for this circuit we have to calculate VTH. So how do we calculate VTH? Simply we have to remove the load resistance RL. Now you may observe here that load resistance is having no value. यहाँ पे कुछ भी value नहीं दी है load resistance की, right? And it is not necessary as well. Okay, because anyway we are going to remove it. मतलब हम अगर हमें कुछ वैल्यू दी भी है आरएल रेजिस्टेंस की, सो देन आल्सो इट डजंट मैटर बिकॉज वी आर गोइंग टू रिमूव दैट एंड वी आर गोइंग टू calculate voltage across these terminals. Let us suppose this is these are the terminals A and B. Okay, so we are going to calculate resistance, sorry, voltage across these two terminals. Okay, so what we are going to do, first of all we are going to remove RL. So I have removed RL now. So what I have to do, I have to calculate voltage across this terminals. So what can be the voltage? Can anyone tell? What will be the voltage across the terminals A and B? This is A and this is B. Anyone can try it? Think about it and you can easily tell me the value of voltage that will be coming across. Okay, Srishti says 3 volt. Anyone else? So yeah, obviously it is 3 volt. How it is 3 volt? See guys, this is open branch. Now we have removed resistance RL, so that's why this is open branch, and the current flowing through this branch is 0. Right, current flowing through this branch is 0, and if the current is 0 then the voltage across this 2 ohm resistance will be 0. That means it is nothing but a short circuit. इसमें कुछ भी voltage नहीं है, ना ही कुछ current है. So whatever be the voltage here, the same voltage will appear here. Okay, so this is going to be 3 volt only. So we can say VTH is equals to 3 volts. Did you understand this? See, sometimes it might need like we have to do some complex calculations, but for this case it was very simple to find out VTH. Okay, so did everyone get like how do we find out VTH? We just have to remove the load resistance and we have to calculate voltage across it, voltage across the open terminals. Okay, except Srushti, why others are not responding? Don't you understand? अगर समझ में नहीं आया है तो बताओ, मैं रिपीट कर दूंगा, इसमें कोई दिक्कत नहीं है. ओके, या वेल, ओके, फाइन. शुभम, शार्दुल, ओके, थैंक यू. अखिल, Aditya, did you understand? All right, so this is the calculation of VTH. And guys, yeah, good. So remember, there's nothing like anything extra in it. You just have to remove the load resistance RL. You can write, okay, you can write the steps for calculation of VTH. Remove load resistance and calculate voltage across the open terminals. That's it. This is the calculation. This is the procedure for calculation of VTH. Now next step we have is calculation of RTH. See guys, I hope you are understanding why we are calculating VTH and RTH. Okay, so we have this much complex circuit. This is a complex circuit, isn't it? And we have to replace this with only two elements, that is VTH and RTH. Okay, so for that we are calculating VTH first and then RTH. Okay, so that's why we are calculating VTH and RTH. You can see here. Okay, now we know how to calculate VTH. Now we have to calculate RTH, that is Thevenin resistance. Okay, so how do we calculate this? There are two, what I can say, two types or two methods. Okay, so you can, guys, you can note down this. Okay, so first type is, you can please note down this because you're gonna maybe forget it. Okay, so please note down. First type is when the circuit contains when the circuit contains uh, independent sources only. Okay, so the first type is when the circuit contains independent sources only, like it might be a current source or it might be a voltage source. Okay, so this is first type. So there are certain steps in this also. So first step is what? First step is remove RL. फर्स्ट स्टेप इज रिमूव आरएल, हमें आरएल को रिमूव करना है. सेकंड स्टेप इज वी हैव टू रिप्लेस ऑल इंडिपेंडेंट sources by their internal resistances. Now what does that mean? अब इसका मतलब क्या होता है? मतलब अगर वोल्टेज सोर्स है तो उसे हमें क्या करना है? शॉर्ट सर्किट करना है. Okay, and if current source is there, so we have to open circuit it. That means we are considering the internal resistance of voltage source as 0 and internal resistance of current source as infinite or very high. That's why we are ओपनिंग द करंट सोर्स. ठीक है, तो अभी मैंने यहाँ पे क्या कहा इन दो फॉर्मूला या फिर इन दो स्टेप्स में, अगर समझ में नहीं आया तो कोई दिक्कत नहीं, विल टेक वन एग्जांपल एंड विल ट्राई टू सॉल्व इट. ओके, so yeah, let us suppose guys we have one example here. Let me just draw the example. That is, this is two. Okay, this is one resistance, this is again another resistance. We have one voltage source here, and again one resistance is here. This is 2 ohm, this is 2 ohm, this is 1 ohm, and this is RL. Okay, so this is RL and this voltage source is 4 volt. So guys, don't get confused, like I'm using this symbol for the voltage source. This is the independent voltage source only. It is not dependent voltage source. Okay, I hope you understand this, right? So what we have to do, first step is what? First step we have to remove load resistance RL. Raman, you are late today. Okay, you are 15 minutes late, Raman. That is not acceptable because it is going to hamper you only. We have seen the calculation of, yeah, don't be sorry. It's not like, it is not problematic for me. Okay, so yeah, uh, guys, remove the load resistance RL. We are going to remove load resistance RL. Here we go. Okay, and now second step is, what is second step? Second step is we have to replace all independent sources by their internal resistances. Now first of all we have to observe whether there are independent sources or dependent sources also there in the circuit. So as you can see, there is only one voltage source, and that is also independent. So we have to replace this independent voltage source by its internal resistance. तो हमने क्या बोला था कि voltage source के लिए what we will do, short circuit or open circuit? What we are going to do, guys, short circuit or open circuit for voltage sources? It is short circuit, and for current sources it is open circuit, right? So what I will do, I will just remove this 4-volt source, and I will short circuit these terminals. Okay, so now we have to find out RTH in these terminals, right? So RTH calculation will be here. So guys, as you can see, this is 2 ohm resistance, this is 2 ohm resistance, both are in parallel, and I have already told you, like, if two equal resistances are in parallel, so their equivalent will be, what will be their equivalent? Half of the one of the resistance. So 2 ohm resistances are here in the parallel. So इन दोनों का जो equivalent है वो रहेगा 1 ohm, and that will be in series with this 1 ohm. So RTH will be 2 ohm. All right, any issue, difficulty? No, it shouldn't be there, is it? So guys, this was the first type of calculation of RTH. Now this method is not applicable when there are independent sources present in the circuit. Okay, so let us suppose independent sources are present in the circuit. So in such cases, what we are going to do? Okay, what we are going to do? So write down the steps. I will just write it for you here. So the second type is when the circuit contains independent independent and dependent sources. Dependent sources. So I hope you are writing. Okay, now first step will be, again, first step will be remove RL. Second step will be replace RL with a voltage source V, and I is flowing from it. Okay, so replace RL with a voltage source V, and current I is flowing from it, and calculate calculate V by I. So V by I will be equal to R only, right? So third step is, again, third step, like it should be actually second step, but it is now I'm writing third. So here also we have to replace independent sources only. Replace independent sources by their internal resistances. Okay, so ये एक्चुअल में सेकंड स्टेप है, एंड द सेकंड वन इज थर्ड वन. ठीक है, पहले हमें लोड आर एल को रिमूव करना है, देन वी हैव टू रिप्लेस ऑल द इंडिपेंडेंट सोर्सेज बाय देयर इंटरनल रेजिस्टेंसेस, एंड द थर्ड स्टेप इज वी हैव टू रिप्लेस आर एल, और वी हैव टू connect a voltage source V, and we have to show that I is flowing through that voltage source, and we have to calculate what? V by I. So V by I will be equal to R, that is nothing but our RTH. Okay, now for to make your life easy, what you can do is you can take the value of that current I is equals to 1. It is optional. Okay, if you feel comfortable, you can take the value of I is equals to 1, and the answers will be correct, guys, don't worry. Okay, like sir, how can we take 1 ampere on our own? It is not like that. Okay, it will work. So until and unless I give you one example, it will be quite difficult for you to calculate RTH, right? So we'll take one example here. So guys, yeah, I'm drawing one circuit here, and what you have to do, you have to just calculate RTH. Don't calculate VTH and all. Okay. So let me just find you the circuit. Okay, good. I have a circuit. Okay, guys, start drawing on your notebook also. Okay, because you have to calculate RTH here. And here we have the voltage source. Okay, and then we have a resistance here. In a dependent voltage source. Sorry, it is current source. My bad. It is dependent current source. Again, we have a resistance here, and we have a independent current source again here. All right, and we have RL here. So RL is this. So let me just give values for these all things. This is 2 volt. This is 1 ohm. This is 3 ohm. This is 2 ohm. This is 2 ohm. This is 4 ohm. This is, guys, 2x, and this is 1 ampere. And the current flowing through this branch is X. Okay, so this is the circuit in front of you. Now what you have to do, you have to calculate RTH. So the first step will be, guys, to remove load resistance RL. Second step will be, we have to replace the internal resistances, or the independent voltage sources or current sources by their internal resistances. So here we have three voltage sources. No, sorry, three sources. Actually, first one is voltage source, that is 2 volt. Second one is current source, that is dependent current source, whose value is 2x. And third one we have is a current source whose value is 1 ampere. Okay, so these are the sources we have. So first thing, remove RL, replace it with V, and the current I is flowing through it. So let me just tell you guys how you are going to do. So see, I have removed RL from here. Okay, and as I said, you have to put one voltage source V here. Okay, so this is voltage source V, and current I is flowing through this. Okay, now next step is what? Next step, we have to replace all the independent voltage sources and current sources by their internal resistances. So the current source here will be open circuit, मतलब यहाँ पे कुछ भी नहीं होगा, and the voltage source here will be short circuit. Sorry, I'm very bad at drawing, I know. Okay, so this is the circuit, guys. Now you have to solve for the V by I, or you have to calculate. Yeah, you have to calculate V by I. Please try it. Okay, I'm gonna solve it. No issues about it, but please keep trying. So yeah, are you trying, guys? I'm waiting for you. Yeah, trying. Well, so try to find out V by I. ट्राई करो, मतलब थोड़ा सा मुश्किल है, but this will help you to understand most your more concepts. Okay, So when done trying, please let me know. Okay, so that we can continue. I can continue basically. Guys, I have simplified circuit for you. So see, okay. Shall I explain? Shall I explain or wait? Okay, okay, okay. Good. No problem. No issues. Anyone else who's solving? All right, all right, all right. RTH is equals to V by 3x. Well done, Raman. But actually, we have to find out a numerical value. Okay. V is imaginary here. V is we have taken. It is not given in the example. Okay. So we are responsible for finding the value of V, isn't it? Now, ठीक है. Uh, what is happening? Okay, wait. So guys, see, this current source is opened, so no current is flowing through this terminal. Okay, so 0 ampere is flowing through this. Okay, so I is flowing through this, so I is going through this resistance, going through this resistance also. So here the current will be what? Sorry, voltage will be 2I, isn't it? I is entering in this resistance. 2 into I is 2I. Here we have the voltage as 3I. किसी को कोई डाउट यहाँ तक नहीं होना चाहिए. Simply I. Okay. All right. Now, see, X is entering from here, isn't it? So X voltage will be here. All right. तो यहाँ तक तो हमने कर लिया. Now, see, this is one node and there are three currents coming here. X is coming here, X is coming here, 2X is coming here, and I is coming here. So X I plus X plus 2X is equals to what? Tell me. It should be what? KCL. No, it should not be S. It should be 0. Okay. Yeah, it should be 0. Did you understand this? All right. Now, 3x is equals to minus I. Okay. So x is equals to minus I by 3. X is equals to minus I by 3. यहाँ तक ठीक है? Okay. Everyone is with me? Guys, please keep quickly responding in the chat box so that we can move quickly. Okay. Yeah. All right. So see, what is the voltage here at this point? What is the voltage here at this point? Voltage V is there, na? V is there, right? Yes or no? Yeah. Now, see, we are going from positive to negative. We are going, see, this is this side, and we are going from positive to negative. So what will happen? The voltage here will be V minus 2I. At this point, the voltage will be V minus 2I. अगर मैं गलत जा रहा हूं तो मुझे बताना. All right. Now, this is V minus 2I, and again we are going from positive to negative. So again what will happen? Subtraction, or the 3I will be subtracted from V minus 2I. So what it will become? V minus 5I. ठीक है? All right. Yeah, fine. अखिल, बाकी लोग, आदित्य. Okay, okay, fine. So 5 V minus 5I is here, and if we come from this side, so what will be the voltage at here? Please, you tell me. You tell me. What will be voltage at this point? If we come from left side, what will be the voltage at this point only? I'm asking about this point only. If we come from this side, what will be the voltage at that point? It will be minus x. Yeah, it will be minus x. So on this same point, we have voltage V minus 5i and we have voltage minus x. So can we write like this? Minus x is equals to V minus 5i. ठीक है ना? Yeah, we can write like this. And what is the value of x here? Value of x is I by 3. Okay. So what I will do? Minus of minus I by 3. Okay. So minus of minus I by 3. So I will simply write I by 3 only. I by 3 is equals to V minus 5i. All right. Now 3 goes here. So I is equals to 3V minus 15i. 15 goes here. Okay. So it will be 16i is equals to 3V. I goes here, 3 goes here. So V by I is equals to 16 by 3. V by I is equals to 16 by 3. And which is our RTH. V by I is RTH, R ना. V is equals to IR होता है तो V by I is equals to R होगा. So this is how we calculate RTH. ठीक है. थोड़ा सा मुश्किल है लेकिन यू हैव टू, जैसे मैंने कहा ना कि आपको एनालिसिस करना पड़ेगा. एंड गाइस रिमेंबर दीज आर लाइक मीडियम लेवल क्वेश्चंस. मैं बहुत मतलब इजी और मीडियम लेवल के ही क्वेश्चंस ले रहा हूँ बिकॉज you need to first of all understand the concept, and when you keep practicing na, then you will be uh, able to solve the gate level questions. These are not actually gate level questions, these are just to improve your understanding. Okay, okay, fine. So this is RTH. So the value of RTH is equals to 16 by 3 ohm. So guys, I'm repeating the steps again to calculate RTH. Just remember, if circuit contains only independent sources, in that case you have to just remove the RL and you have to replace all the independent sources by their internal resistances, which means you have to replace voltage source by short circuit and current source by open circuit. For what? For independent sources. अगर independent और dependent दोनों sources है, so in that case you have to first of all remove RL. Okay, then you have to replace all the independent sources only. Dependent sources को replace नहीं करना है. You have to keep dependent sources as it is. They will help you to find out the answer. Okay, don't worry about it. अगर dependent source को remove कर दिया तो फिर आंसर गलत आ जाएगा. And after that, अगर डिपेंडेंट सोर्स सर्किट में है तो यू हैव टू पुट वन voltage source V in place of resistance RL, and we have to show that current I is flowing through it. See, मैंने यहाँ पे दिखाया था ना कि I flow हो रही है इस voltage source में से current. For your convenience, you can take I is equals to 1 also. Some calculations will change, but the final answer will be same. Okay, now your homework or activity, you can say, will be this. Just take the screenshot of this particular page, or don't worry, I will share this on your group also. Okay, so try finding the value of RTH by putting the value of I is equals to 1. Okay, you have to only make one change, that is I is equals to 1. All other calculations will be changed. बाकी सारे कैलकुलेशन चेंज हो जाएगी. ओके, सो प्लीज ट्राई इट. ओके, नाउ ट्राई दिस. फाइंड VTH. सो VTH फाइंड करने के लिए सबसे पहली स्टेप तो हमें क्या होती है कि रिमूव RL. सो यहाँ पे ऑलरेडी RL को रिमूव कर दिया गया है. सो व्हाट इज रिमेनिंग? we have to simply jump onto it and calculate the voltage across terminals A and B. We don't have to replace anything. Like this is we are calculating VTH. All right. So can you do this? I will give time of 1 or 2 minutes, not more than that. Okay, because I know like I'm asking you people to solve all the questions, but the motto behind that is You will get used to solving the questions. Okay, so jump onto it, guys. Try solving it. Okay, go for it. Hmm. Okay, fine. So it is 2 minutes. It's already 2 minutes. Okay. So guys, where do we start? First things first. Where do we start? We have to start from here, guys. See, yeah. So we have to find out the voltage across this terminal. VTH. Here we are going to get VTH. So since the value of current in this branch is zero, whatever will be the voltage here will be the same voltage VTH, and whatever will be the voltage Vx, that will be the same voltage VTH. All right, somebody has got 2 volt. Okay, 2 volt. Fine, fine. We'll discuss it. Okay, now let us suppose we have to calculate voltage across these two terminals. All right. So 1 ampere current is this. So let us suppose current I is flowing through here. All right. Now, why I'm assuming current I is flowing through this? Like, is it on in our procedure? No, it is not in our procedure. ओके हमारी प्रोसीजर क्या थी सिर्फ आरएल को रिमूव करना है और वोल्टेज कैलकुलेट करना है यू कैन यूज एनीथिंग केवीएल केसीएल एनीथिंग एनी लॉ ठीक है यू कैन नॉट जस्ट रिप्लेस इट मतलब रिप्लेस हम हमें तभी करना है जब हमारे एसओपी में दिया है राइट सो आई इज टेकन हियर सो फ्रॉम आई 1 ampere is going here so what will be the current through this I minus 1 ampere current will be flowing through this isn't it so what will be the voltage across it voltage across it will be 6I minus 6 positive negative ठीक है ना 6I minus 6 guys okay रिप्लाई करना चैट बॉक्स में सी 6 ओहम का यहाँ पे रेजिस्टेंस है I minus 1 करंट फ्लो हो रही है so 6 will be multiplied with this current and it will be 6I minus 6 voltage across these terminals okay so value of Vx is 6I minus 6 ठीक है okay Srishti has written Vx is equals to 2 volt is equals to VTH okay Srishti will try it we'll solve it okay so see Vx is equals to 6I minus 6 यहाँ तक तो सबको आ गया I hope now this is independent voltage source so यहाँ से start करेंगे हम guys so it will be minus 2 Vx now what will be the current through this sorry voltage across this will be 3I plus Vx is equals to what is equals to 0 ठीक है ये जो मैंने स्टेप लिखी ना यहाँ पे आई थिंक वी एक्स इज इक्वल्स टू 1.2 1.5 ओके ओके विल वेट ना विल सी ठीक है तो यहाँ तक तो सब लोग मेरे साथ हो ना कि मैंने माइनस 2 Vx प्लस 3I प्लस Vx क्यों लिखा इज इक्वल्स टू 0 क्यों लिखा बिकॉज आई अप्लाइड द केवीएल हियर इन दिस लूप ठीक है ये Vx था ये माइनस 2Vx है और ये 3I है गाइस ओके एनी कंफ्यूजन अगर हो तो बताना अगर कोई स्टेप समझ में नहीं आती ना इमीडिएटली टेल मी आई रिपीट इट ओके अगर आपका कोई रिप्लाई नहीं आ रहा है तो मैं समझ के चल रहा हूँ कि आपको समझ रहा है ठीक है सो अभी Vx की वैल्यू क्या है? Vx की वैल्यू है 6i-6. Vx की वैल्यू है 6i-6. सो आई विल रिप्लेस द Vx माइनस 2. Vx की वैल्यू है 6i-6 प्लस 3i प्लस Vx की वैल्यू है 6i-6 is equals to 0. So simplify it. Minus 12i plus 12 plus 3i प्लस 6i-6 इज इक्वल्स टू 0. अगर मैं कहीं पे गलत जा रहा हूं तो मुझे जरूर बताना. ठीक है. इफ यू थिंक लाइक I'm going in a wrong direction, you can tell me. So minus 12i plus 3i plus 6i, this is 9i. 9i minus 12i, that is minus 3i, and 12 minus 6 is plus 6 is equals to 0. So 6 is equals to 3i. All right. So I will be equal to 2 ampere. ठीक है. अभी I is equals to क्या आया हमारा? 2 ampere आया. So we know that Vx is equals to 6i minus 6. So Vx is equals to 6 multiplied by 2 minus 6, that is 12 minus 6 equal to 6 volt. So Vx मेरा अगर 6 volt आता है, so मेरा RTH भी guys 6 volt ही, sorry RTH या फिर VTH, क्या लिख रहा हूं मैं यहाँ? VTH is equals to भी 6 volt आना चाहिए. I hope it is clear for everyone. Is any issue, difficulty, or did I I made mistake somewhere? मतलब आपका वोल्टेज तो 2 वोल्ट आ रहा था, मेरा किस रमन का तो 1.2 आया और मेरा 6 वोल्ट आया VTH. Is clear or any confusion? Like you are not responding, so I'm afraid like you did you understand anything or not? Akhil, Shubham, Aditya, Shardul, clear na? Okay, don't worry. I'll share this PDF with you. Okay, I'll share this PPT with you, so you can again go through it. ठीक है. तो VTH क्या आया हमारा? 6 वोल्ट आया. ठीक है. मेरे स्टेप्स कुछ अलग रह सकते हैं, लाइक यू कैन यूज डिफरेंट स्टेप्स, बट आंसर तो सेम ही आना चाहिए ना, whatever step you use, isn't it? So yeah, find RTH now, guys. This you have to do. Yeah, this is easy. RTH फाइंड आउट करना है गाइस, और इसमें आपको प्योरली इंडिपेंडेंट सोर्सेस दिया है. So you don't have to put any V, I, and nothing. You just have to replace the sources, and you have to simply calculate RTH. So time limit for this is 2 minutes. It is 9:15. At 9:17, I will start explaining this example. Everyone, please try. Give it a try. Even if you make mistake, no worries. Find RTH. So guys, let me again just रिवाइज इट कि हम ये VTH और RTH क्यों निकाल रहे हैं, आपको समझ रहा है ना? वी आर एमिंग टू सिंप्लीफाई द सर्किट. ओके, जो VTH की वैल्यू आ रही है उसे हमें इन व्हाट वी कैन से सीरीज में रखना है, रेजिस्टेंस RTH के और RL के, एंड दिस विल बी आवर सिंपलेस्ट सर्किट. ऑल राइट. ऑल राइट. So what is the resistance, guys? Can anybody tell? What is RTH? Yeah, it's 917. So guys, please concentrate. Okay, हमें यहाँ पे RTH कैलकुलेट करना है. Simple steps. Replace the independent voltage sources by their internal resistances. करंट सोर्स जो है वो तो यहाँ से निकल ही जाएगा. ठीक है. और ओके, वेट अ मिनट. ओके, ओके, फाइन फाइन रमन. ठीक है, 1 more minute, नो इश्यूज. टिल देन आप लोग भी ट्राई करना. अभी तो मैंने एक हिंट भी दे दिया है. ओके रमन, नो वरीज, फाइन. You keep solving. I will explain them. Okay. So this 4 ampere current source plays no role here. Okay, Shardul has got some answer, 30 by 19. Okay, Shardul, we'll see. Srishti got the answer 9 by 4. Okay, Srishti, we'll see. Okay, fine. ठीक है. 2.25, just missed it, I think. Okay, no worries, we'll see. 2.22, no. Okay, wait. See, everybody, please stop solving. I'll explain you. So remove this internal, sorry, remove this current source. It will be open circuit. So see, this is 8 ohm resistance. This is again a 8 ohm resistance, guys. 3 and 5 are in series now after removing the removing the current source, isn't it? So 8 ohm resistance is parallel with 8 ohm resistance. So what will be the resultant resistance? Obviously it will be 4 ohm resistance. No need to calculate. Two equal resistances are parallel, then the equivalent resistance will be half of one of them. 4 ohm resistance. ठीक है. ठीक है. तो अभी यहाँ तक तो हम आ गए. नाउ आई विल सिंप्लीफाई दिस सर्किट. ओके, सो देखना जरा. दिस इज 4 ओहम रेजिस्टेंस. ठीक है. और यहाँ पे जो नीचे रहेगा, यहाँ पे तो हमारा जो वोल्टेज सोर्स है वो तो शॉर्ट सर्किट हो जाएगा. ठीक है, उसका तो कोई सिग्निफिकेंस ही नहीं है यहाँ पे. तो 4 3 12 12 एंड वो शॉर्ट सर्किट करना है. ओके, let me just see it again. 4 3. Okay, 4 3. This is 4 ohm resistance. This is 3 ohm resistance. And we have a 12 ohm resistance here, a 12 ohm resistance here, and we have to calculate RTH here. So let me just give the values: 12 ohm, 12 ohm, 3 ohm, 4 ohm, 4 ohm, and this is short circuit. This is voltage source now. Okay, 13.2, 30 by 2. Okay, wait, Raman. Now focus. Okay, now guys, don't you think these two resistances are in parallel with each other? Don't you think these two resistances are in parallel? Yes or no? Yes, they are in parallel. They are in parallel, na? So 12 multiplied by 4. 12 multiplied by 4 is 48. 48 divided by 16. What it will be? 3 ohm. ठीक है. So 3 ohm हमें किस तरह से कनेक्ट करना है? We have to connect 3 ohm like this. So see, मैं कनेक्ट कर देता हूं यहाँ पे. 3 ohm का रेजिस्टेंस हमारा इक्विवेलेंट आ गया. ओके, so 3 ohm resistance will be connected like this. Sorry, ये 3 ओहम रेजिस्टेंस रहेगा और इसका एक जो टर्मिनल है वो दोनों टर्मिनल को कनेक्टेड रहेगा यहाँ पे. सॉरी, वेट. हाँ, या सो हो गया भाई, सिंप्लीफाई. आंसर इज 2 ओहम. सॉरी सर, डिड ओके, या इट हैपेंस, नो इश्यूज. सो आंसर इज 2 ओहम, व्हिच इज करेक्ट. ओके, नाउ सी, this is 3 ohm in series with 3 ohm. 3 plus 3 is 6. 6 ohm is again parallel with 12 ohm. Okay, so 6 multiplied by 3 is 72. Okay, let me just solve it. ओके, सो अभी सर्किट हमारा कैसे बन रहा है मैं आपको बताता हूँ दोस्तों. ठीक है, सी, दिस इज 4 ओहम रेजिस्टेंस. दिस इज 6 ओहम रेजिस्टेंस, दिस इज 4, दिस इज 6 एंड दिस इज 12। एंड यहाँ पे हमें आरटीएच कैलकुलेट करना है, ठीक है। ये 4 ओम कहाँ से आया, ये जो ऊपर का जो 4 ओम था ये यहाँ पे है, ये 3 प्लस 3 6 बना, और ये 12 बना। ओके, नाउ कैलकुलेट द वे यू वांट टू। सो 6 into 12 is 72, 6 into 12 is 72, divided by 6 plus 12, that is 18। so 18 fours are 72, मतलब इन दोनों का मिला के क्या बना, 4 ohm resistance बना, which is again in parallel with this 4 ohm। so two 4 ohm resistances are in parallel, so the equivalent will be RTH is equals to 2 ohm। I hope this answers the query or the any difficulty problem you had। All right, now just focus on your mistakes, guys, like Srishti, Raman, you guys tried, and who else, Shardul, okay, Shubham also tried। Okay, so just find out where did you make committed the mistake, ठीक है। Yeah, good। So guys, this is for your homework, I'm not going to solve this for you, this is for your homework। You can calculate VTH and RTH, and guys please post like if you solve it, post it on the group, no issues, you can post it on the group, okay। Yeah, so I hope you have taken the screenshot, and even if you have not taken the screenshot, the PDF will be available for you। Now next thing we have is Norton's theorem, guys। Norton's theorem is nothing new rather than nothing new than uh, Thevenin's theorem, okay। Norton's theorem में RTH का जो कैलकुलेशन है, सी मैं आपको अभी, हमारे पास 7 मिनट है तो 7 मिनट में आपको बता देता हूँ चीजें। और shall we extend this, guys? I don't think we shall extend, okay। I'm not in mood of extending the class, okay। we will keep it for 1 hour only, all right, ठीक है। so yeah, so Norton's theorem में देखो हमें क्या करना है। Norton's theorem again simplifies a complex circuit, so this is a complex circuit, okay, and it has a load resistance RL। so it again simplifies into such that, see, this is a current source IN, that is Norton current, okay। and तो हमें पता है कि करंट सोर्स के पैरेलल में हमेशा एक रेजिस्टेंस रहना चाहिए। सो दिस इज आर एल, दिस विल बी आर एन, ठीक है। ये आई एन है, ये आर एन है, और ये आर एल है। सो गाइज, नॉर्टन थ्योरम और थेवेनिन थ्योरम में आपको एक डिफरेंस समझ में आया होगा कि थेवेनिन थ्योरम इज ऑल अबाउट वोल्टेज, वीटीएच कैलकुलेट करना है, आरटीएच कैलकुलेट करना है, वीटीएच के सीरीज में हमें आरटीएच को रखना है, ठीक है। नॉर्टन्स थ्योरम में हमें आई एन कैलकुलेट करना है, आर एन कैलकुलेट करना है, और आर एल तो सेम ही है। सो गाइज, ओनली वन डिफरेंस इज देयर, ओनली वन डिफरेंस, ओके। आर एन इज इक्वल्स टू आर टी एच, सी आर एन इज इक्वल्स टू आर टी एच। जिस तरीके से आप आर टी एच कैलकुलेट करते हो, सेम स्टेप्स यू हैव टू फॉलो टू कैलकुलेट आर एन ऑल्सो, कुछ भी चेंज नहीं है, ओके। लेट इट बी एनी सर्किट। अभी आई एन कैसे कैलकुलेट करना है, आई एन कैलकुलेट करने के लिए, फॉर एग्जाम्पल गाइज, मैं आपको एक एग्जाम्पल देता हूं, जस्ट वेट अ सेकेंड, ओके। लेट मी जस्ट फाइंड द एग्जाम्पल, प्रॉपर एग्जाम्पल फॉर यू, okay। So here we have the example। so let us suppose this is a circuit, sorry for the bad drawing, guys, I'm very bad at drawing, I know। this is 2 ampere, this is 1 ohm, this is 2 ohm, this is again 4 ohm, this is 4x, okay। so 4x is here, and the current x is flowing through this, okay। now next we have is, this is 4 volt, this is 2 ohm, एंड दिस इज आर एल, ठीक है। तो दिस इज, सी सिमिलर सर्किट इज देयर, इसी तरीके का सर्किट हमें थेवेनिन थ्योरम में भी देखने को मिला था, ठीक है। तो हम क्या करते थे, व्हाट वी यूज्ड टू डू गाइस फॉर कैलकुलेटिंग वीटीएच, वीटीएच कैलकुलेशन के लिए हम क्या करते थे, जरा बताना मुझे। वी यूज्ड टू रिमूव आर एल, हमें आर एल को रिमूव करना है, और वहां पे हमें वोल्टेज फाइंड आउट करना था. दिस वाज द स्टेप टू कैलकुलेट वीटीएच. Replace VTH. No, no, Raman. Sorry, Srishti. See, this is what I can say. This is the confusion you are doing. Okay, Srishti, we have to replace VTH and I. ये हमें कब करना है? Yeah. Okay, sorry. My bad. नहीं, सृष्टि, you are wrong. बिकॉज वीटीएच कैलकुलेट करने में हमें कुछ भी रिप्लेस नहीं करना होता है. वी जस्ट हैव टू रिप्लेस आरएल. हमें आरएल को निकालना है एंड एट दैट टर्मिनल वी हैव टू कैलकुलेट वोल्टेज. यही करना है. ओनली स्टेप इज देयर. जब हम आरटीएच कैलकुलेट करते हैं तो तब हमें वोल्टेज सोर्स, करंट सोर्स, उसको रिप्लेस करना होता है. इजंट इट? आरटीएच के कैलकुलेशन में. वीटीएच के कैलकुलेशन में हम कुछ भी नहीं करते, सिर्फ इस आरएल को निकालते हैं और उसके मतलब जो टर्मिनल ओपन हुए हैं वहां पे हमें वोल्टेज निकालना होता है. सो गाइज, सिंपल स्टेप फॉर नॉर्टन्स थ्योरम इज इस आरएल को हमें रिप्लेस करना है. यहां पे वीटीएच में हम क्या करते थे? वोल्टेज निकालते थे. यहाँ पे हमें करंट निकालना है. इस जो टर्म वो ये जो दो टर्मिनल्स है ना, इसको शॉर्ट कर दो और यहाँ पे जो करंट फ्लो होगा ना, आई एन, दैट विल बी आवर नॉर्टन्स करंट. इंस्टेड ऑफ फाइंडिंग वोल्टेज वी आर फाइंडिंग करंट थ्रू दिस ब्रांच. आर एल को रिप्लेस करो, उसको शॉर्ट सर्किट करो और उसमें से जो करंट फ्लो हो रहा है आई एन, दैट विल बी आवर आई एन फॉर दिस. ये आई एन हमारा वही होगा. आर एन इज इक्वल टू आर टी एच, तो पता ही है हमें. मतलब आर एन और आर टी एच के कैलकुलेशन 100% सेम है. मतलब उसमें थोड़ा सा भी डिफरेंस नहीं है. ओके, डिफरेंस क्या है? सिर्फ वीटीएच की जगह पे आरटीएच हम यहाँ पे कैलकुलेट करेंगे. ठीक है. तो जो नेक्स्ट टॉपिक गाइज है हमारा, वो रहेगा मैक्सिमम पावर ट्रांसफर थ्योरम. उसके बाद में सुपरपोजिशन थ्योरम एंड वन मोर थ्योरम इज देयर. व्हिच थ्योरम इज देयर? रेसिप्रोसिटी थ्योरम. ठीक है. दीज थ्री थ्योरम्स आर देयर. स्लिप ऑफ टंग, सॉरी. सो ये तीन थ्योरम हम कंप्लीट करेंगे. इसी के साथ साथ हमारे जो नेटवर्क थ्योरम है वो कंप्लीट होते हैं. गाइस, देयर आर सर्टेन अदर थ्योरम्स आल्सो, मिलमैन्स थ्योरम एंड अदर थ्योरम्स, बट they are not in the syllabus included, included in the syllabus, so we are not going to invest our time on those theorems. Okay. So guys, as of now I can't share this ppt with you. Like, I'm not saying that I won't share this with you. I will share this with you in the next class. Why? Because there are certain examples that I need to like, there are certain slides that is remaining. Okay. So is it okay guys if I share this ppt next week to you? Is it okay guys? Okay, fine. ठीक है. So just okay, fine, thank you. So just take the screenshot of this question and please try to solve it. VTH calculate करना, RTH calculate करना, and if possible नॉर्टन्स इक्विवेलेंट भी कैलकुलेट कर लेना, आई एन भी कैलकुलेट कर लेना. ठीक है, आई एन ही बच रहा है ना. तो अगर ये तीन चीजें अगर आप कैलकुलेट कर लेते हो, सो इट विल बी वेरी गुड प्रैक्टिस फॉर यू. ठीक है. So guys, it's 9:30. No, it's 8:30. Okay, why I'm saying 9? Okay, no problem. So it's 8:30 and I think we should conclude our today's class here. So tomorrow we will be having, guys, uh, sorry, control systems. Okay, tomorrow we will be having control system class. Okay, yeah, it's fine. My pleasure, Srishti. No issues. Thank you. Okay, yeah. Bye, guys, and you are free to leave the class. Thank you. Bye bye. Yeah, bye, everyone.